Om Swastiastu. Hello, good morning, Prof. and friends. This morning, I would like to present you a video about to finish my English lecture. The topic in this video is about bridge. Enjoy the video and I hope we always be in a good condition. But before it, I'm going to introduce myself. My name is Putu Surya Budiana. My name is 2205511020 and my class is class 1. Okay, after that we can start the video with the title is bridge. The first is about definition of bridge. A bridge is structure made to cross a chasm or obstacle. The bridge can also be interpreted as a complementary road building that functions as link between the disconnect ends of the road. Bridges are also part of the land transportation infrastructure, which is very vital in the flow of travel. Bridges are often a critical component of a route because they determine the maximum loads of vehicle passing through it. After that, we're gonna discuss about various types of bridge. Log bridge. A log bridge is made of wood with a relatively short length and relatively light load. This bridge is usually passed by foot, bicycle, or two-wheeled motor vehicle. Stone or brick bridge. A stone or brick bridge is a bridge with a top and bottom structure made of river, stone, or red brick. This bridge can be interpreted as a type of bridge with a gravity system whose strength releases on the weight of the structure. Pretest concrete bridge. A pretest concrete bridge is a bridge with pretest concrete construction material or concrete containing steel cables to prevent initial stress in the form of tensile stress to the concrete due to nature of concrete which is unable to withstand tensile force. Reinforced concrete bridge. Reinforced concrete bridge are bridges whose construction use concrete material and is used for highway construction. An ordinary reinforced concrete bridge has a span of 50 until 25 meters. The reinforced bridge structure itself consists of superstructure, foundation, substructure, foundation, embankments, and bridge girders. Concrete foundation structure are generally reinforced with a thickness of up to 25 centimeters. Reinforced concrete itself is reinforced concrete with an area and amount of reinforcement not less than its minimum value. Steel bridge. A steel frame bridge is a bridge structure consisting of a series of steel rods connected to one another. This bridge is generally used for bridges with long spans with a large enough load. This bridge uses various steel structural components and systems such as decks, girders, trusses, arches, supports, and cable hanger. Composite bridge. A composite bridge is a bridge that combines two or more different materials. Composite bridges that are generally used are a combination of steel and reinforced concrete construction material, namely by combining steel as the deck and reinforced concrete as the bridge floor plate, which work together to support the load as a single beam. The third is about types of bridge construction. 1. Truss bridge. Truss bridge is a bridge that is sturdy in terms of construction because it uses a triangular truss frames. Even though they don't stick to the ground, the bridge pier becomes stiffer because of triangular shapes that connects one pillars to another. In addition, the diagonal lines of the bridge pier also serve to transfer the load to a wider area so that the load does not gather at one point. Beam bridge, also known as a girder bridge, this construction design is the simplest in making a bridge. Generally, this bridge is straight and horizontal, with vertical pillars as piles to strengthen it. The piles are made of steel or concrete drove into the ground. Beam bridge construction is commonly used to connect two planes that are relatively close. For example, areas separated by rivers. Arch bridge. The arch bridge is a bridge that is made in a curved manner like a bow. Even though the construction shift material does not require a lot of material. In terms of durability, this design is stronger than beams and trusses. The basic work of this bridge is to the transfer of the weight of the bridge and the load on into a horizontal truss which is controlled by the support of both sides. Brick loads are pushed to the abutments on both sides. Arch or semicircle bridge design naturally diverts the load received by the floor of the bridge vehicle to the abutments that keep both sides of the bridge for moving sideways. Cable stayed bridge. Cable stayed bridge are the supporting elements of the traffic in cable stayed cables directly supported by a tower. A cable stayed bridge is a continuous girder with one more tower mounted on the bridge pillar in the middle of the span. Cable-stayed bridges have relatively low center of mass, so this type of bridge is very good for use in areas with an earthquake risk and is used for variation in span length of 100 until 600 meters. Suspension bridge. A suspension bridge is a type of bridge that uses cable tension support rather than side supports. A suspension bridge usually has main cables, steel cables or other chains, anchored at each ends of the bridge. The basic structural system of the suspension bridge is the main cable that carries the suspension bridge. Bridge traffic floor are usually not connected directly to the pillars because principle of girder support lies in the cables. And the last we would like to discuss about bridge construction parts as the parts of the structure that make up the construction of the bridge among others. A. Construction of superstructure. The superstructure of bridge is the part that receives the direct load which include its weight, dead load, additional dead load, vehicle traffic load, brake force, and pedestrian load. The superstructure of the bridge includes 1. Sidewalk. Sidewalk are parts of the bridge serving use for pedestrian facilities which are on the left and right side of the vehicle floors. The height of sidewalk is higher than the level of the vehicle floor layer. Sidewalk consists of backrest and slab for pavement. Vehicle floor and pavement. Vehicle floor and pavement are part of the bridge construction which directly receive the loads that run on it. Longitudinal beams. Longitudinal beams are the main beams that carry loads from the floor of the vehicle and loads of vehicle passing through the bridge, and then these loads are distributed toward the foundation. The size of longitudinal beams depends on the length of the span. These beams serve to transmit the floor loads of the vehicle, dead load and live load, onto the cross beam, transverse beam. These beams carry load through the longitudinal girders and transmit them to the trusses. The transverse girder is a girder that is under the floor of the transverse vehicle with the road axis to withstand to load above it, which is the load from the vehicle floor. The longitudinal girder load and the live load or traffic load above it. Wind teeth. Wind teeth function to transmit wind loads to the main structure of the bridge frame and provide stiffness to the bridge and transmit wind loads to the final portal. The wind loads acts on the knot points. Bridge frame. The bridge frame consists of two parts, including 1. Diagonal frame, 2. Vertical frame. Stiffener. Stiffener are plates used the fulcrum of the beam when the beam lacks the capability in the web of the profile to support the ultimate erection or concentrated loads. Bridge joints. Known by other names as expansion joints, bridge joints, or dilatation covers. This part has an important function for a bridge. This connection function as a distribution of load from one route to another. Without expansion joints, the bridge may not be functional or even endanger the vehicle passing over it. Laying, rollers, and joints. Laying function to channel the load of the bridge to the entire bridge structure. Construction of the substructures. The structure under the bridge function to carry out the loads of superstructure and other loads caused by slow pressure, water flow and drift, and friction on the support to then be distributed by foundation to the subgrids. The structure under the bridge includes 1. Bridge pillars. Bridge pillars are another part of the substructure which is located on the span of the bridge between the abutments of the bridge, functioning as abutments that divide the load and shorten the span of the bridge. 2. Bridge of bridge. The base of bridge is the part that carries the two bases of the bridge which is located at the end of the span of the bridge and function to transmit the entire load of the superstructure to the foundation. Bridge foundation. Bridge foundation serves to transmit the entire load of the bridge to the subgrid. In general, frame bridge foundation use pile foundation and board piles. Okay, there were all of my presentation video about bridge. I hope this video can help you to know about bridge. And also, I would like to say thank you for your attention to watch my video. And the last, Om Santi, 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 Om.